Good morning, good evening, or good afternoon, ladies and gentlemen, boys and girls. Welcome to Mr. P's Believe It or Not segment Relationships in Circles. I'm going to tell you some things. Oh, hello, this is Mr. P signing in. I'm going to tell you some things here in our guided notes, section 10.6 for our secondary math 2 class that seem absolutely amazing, but they are just as amazing as they are true. Vocabulary. Segments of a chord. When two chords intersect the interior of a circle, each chord is divided into two segments, right? If this chord here goes through there, then there's this external segment and a secant segment, or excuse me, an internal segment. And the whole thing is called a secant segment. A tangent segment is a segment that is a tangent to a circular endpoint. So PS would be the tangent segment. The secant segment is a segment that contains the chord of a circle and has exactly one endpoint outside of the circle. So one is outside, one is inside. The external segment is the part of the secant that is outside the circle. The internal segment is the part that's inside. That's not the amazing thing. This is the amazing thing. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segment on the other chord. Now that sounds weird, but watch this. This is what that means, and this is truly, I think, one of the most incredible things in mathematics. What it's trying to tell you is that these two intersect, these two chords, which means that D to E times E to C is equal to A to E times E to B. Those products are equal, which I find amazing. Did you? No? Oh, okay. The segments of the secant is similar. If two secant segments share the same endpoint outside of a circle, then the product of the lengths of one secant segment and its external segment equals the product of the length of the other secant segment and its external segment. Huh? That is to say, the external segment multiplied by the secant segment is equal to the other external segment multiplied by its secant segment. That is, EA times EB equals EC times ED. And that with tangents, it pretty much means the same thing. So EC times ED is equal to EA, and since there is no internal segment, the external segment is the secant segment, EA times itself. EA times EA equals EC times ED. Let's get to it. So, since these two chords intersect, I know that this segment multiplied by this segment is equal to this segment multiplied by this segment. That is, x times x plus 1 is equal to 5 times 6. Distribute. X squared plus 1 times x is x equals 5 times 6 is 30. Now this is a quadratic situation, so let's get it equal to 0, which means x squared plus x minus 30 equals 0. So what multiplies to negative 30 and adds up to 6? Sorry, adds up to 1. I'm just giving the answer away there. That is, I can factor that to x minus 5 times x plus 6, right? Because negative 5 times 6 is negative 30. Negative 5 plus 6 is positive 1, which means x equals 5 or x equals negative 6. Equal to 0, excuse me. I don't know why I said 1 there. That was weird. Anybody catch that? You did? Great. Extra points for you. Just kidding. I can't give you any extra points because I don't know who you are. So can x be negative 6? Well, that distance is x, so no, it most certainly cannot be. But it could be 5, and that could be 6. Oh, look, they're congruent too. Fun. Okay, same story. This length times this length, 10 times 7x, is equal to this length, 15, times this length, 5x minus 2. So 70x equals 15 times 5. You would think I would know that by now. I don't. Equals 75x minus 30. Subtract 75x from both sides. And I get negative 5x equals negative 30. Divide both sides by negative 5 to solve for x, and x equals positive 6. And that's all because this length, this times this is equal to this times this. Now this does something really similar, except remember this time it's the external segment times the external segment plus the internal segment, the whole thing, 3 plus x, is equal to the external segment times the external segment plus the internal segment, which in this case is 12. Distribute that in. 9 plus 3x equals 24. Let's solve this by subtracting both sides. I just want x, right? 24 minus 9 is 15, so 3x equals 15. Divide both sides by 3, and x equals 5. I'm beginning to sense a theme here. Okay, now this one's going to be similar. External times the external plus the internal. 2 times, well, 2 plus x plus 3 equals the external, x plus 2, times the external plus the internal, x plus 2 plus 1. Gross. 2 plus 3 is 5, so 2 times x plus 5 is equal to x plus 2, I had forgot to put parentheses around there, times x plus 3. Ew. Distribute 2x plus 10 equals x squared plus 3x plus 2x plus 6. Put those together. 2x plus 10 equals x squared plus 5x plus 6. Subtract 2x from both sides. 10 equals x squared plus 3x plus 6. Subtract 10. Now, why am I doing this? Because it's quadratic and I want to get it set equal to 0. 0 equals x squared plus 3x minus 4. Can I think of something that multiplies up to negative 4 and adds up? I'm just trying to factor this to make my life easier. Adds up to positive 3. I can. X plus 4 times x minus 1 equals 0. So x equals negative 4 or x equals 1. Now, do both of those work? They most certainly don't, because negative 4 plus 3 is negative 1, and we can't have a negative length. So that means that x equals 1. Finally, this is the same story, except this time it's the external segment multiplied by the secant segment. 9 times 9 plus 7 is equal to the tangent segment times itself, because there is no internal segment to add to it. That is, 9 plus 7 is 16. 9 times 16 equals x squared. Ooh, 9 times 16 is going to be nice. Yeah, it is. 144 equals x squared. Take the square root of both sides, and you get x equals plus or minus 12, but x can't be negative 12, so that's got a distance of 12. Finally, over here, the tangent segment times itself, x plus 1 times x plus 1 is equal to the external segment, x minus 1, multiplied by the external segment plus the internal segment, that's the secant segment, x minus 1 plus 5, that's going to simplify, well, x squared plus x plus 1, and then that's going to be x plus 4, so x minus 1 times x plus 4, and that's going to simplify to x squared plus 2x plus 1. Looks like a 2, I apologize. That's a 1, equals x squared plus 4x minus x minus 4. Oh, that looks familiar. X squared plus 2x plus 1 equals x squared plus 3x minus 4. I remember you from a problem right above there. Anyway, if we take away x squared from both sides, thankfully the x squared terms are gone, leaving me with 2x plus 1 equals 3x minus 4. So I'm going to subtract 2x from both sides, giving me 1 equals x minus 4. Add 4 to both sides, and hey presto, you get x equals 5 again. Did that show up 3 times? I think that showed up 3 times. Hang on. Just real quick. X equals 5. 1, 2, 3. If x equals 5 over here, I'm going to be amazed. The x's show the positions of 2 basketball teammates relative to the circular key on a basketball court. The player outside the key passes the ball to the player on the key. What is the length of the pass? That is this segment multiplied by that whole length is equal to this segment multiplied by that whole length. And that's the pass length. So we're going to call that P. That is 5 times 5 plus 12, that whole secant segment, is equal to the 6 feet plus, times 6 plus P. Now the pass is that 6 plus P, and we'll get to that in a second. So 5 plus 12 is 17. So 5 times 17 equals, distribute, 36 plus 6P. Now 5 times 17 is 85 equals 36 plus 6P. Subtract 36 from both sides. And 85 minus 36 is 49 equals 6P. Divide both sides by 6. And you get that P is about 8.16. Well, 8.17. Okay? Now that's not the whole thing, right? The whole thing is going to be, let's see here. It's going to be 6 plus that number. 6 plus 8.16 repeating, which is the exact. And so we're going to add 6 feet to that. So the pass length was 14.16 repeating feet. Or really, that was about a 14-foot pass. Whew, and there it is, folks. Some strange but true things about the secant and segment relationships in and around circles. I hope you learned a bunch. This is Mr. P signing off. If you have any questions, send a message to your instructor, and I hope you have a most wonderful and fantabulous rest of your day.